So I move to B4. B4 is saying two successive crests of approaching water waves are separated by a distance of 1.8 meters. It takes 0.3 seconds for one crest to cover the distance of 1.8 meters. So here we are now talking about what? We are talking about waves. So this is a what? They are talking about crest, and it is only in a transverse wave where we get to find the crest. So if I draw a wave here, so if I was to draw a wave like this is a wave that I've drawn here. So between two successive crests, we are talking about the distance which is here and the distance which is there. This is what I'm talking about. So on this here, this distance, they're saying between two successive crests, the distance that is there is what? 1.8. So the distance from here to there, the distance which is here is what? 1.8 meters. That is the distance that is there between two successive crests. So then the other question is that it takes 0.3 seconds for one crest to cover the distance of 1.8. So to cover this distance of 1.8, so this distance of 1.8, it is the wavelength here. This is also wavelength. How do we define wavelength? Wavelength is a distance between two successive crests, or it is the distance at which a wave repeats itself. So now here what we are given is what? 0.3 seconds. So this time which we are given here, this is called period time, because you know that under waves, how the way we get to define the period of a wave, the period of a wave is defined as the what? Time taken for a one complete wave. So this is a one complete wave. So this is period time. So what is period time is 0.3 seconds. This is the data that we are given. The first question, at what speed is the wave traveling? At what speed is the wave traveling? The formula for speed, speed is equal to what? Speed is equal to, so speed is equal to distance. Speed is always equal to distance over time. Have you seen? That is the formula that you need to use. So that's the formula that we need to know. Where I'm going to say that speed is equal to, what is my distance? My distance is 1.8 over, what is my time? My time is 0.3, which is equal to what? So when you divide there, what are you going to get? You say 1.8 divided by 0.3. What are we getting? We are getting a 6. So there we are getting a 6. This is a 6 which we are getting. The unit for speed, meters per seconds. So those are the units. Those are the units you need to get. Those are the units you need to understand. So let's make sure we understand that. So we move to this other question. It's saying, what distance is covered by the wave in 2 minutes? What distance is covered by the wave in 2 minutes? So what is the distance covered by this wave in 2 minutes? Now what's the formula? You know that when you go with this formula where you say speed is equal to distance over time, so meaning distance is equal to, you multiply these two, you just make d the subject of the formula, which is equal to speed over time. This is what you are going to do. So what is speed? So speed you already have, which is what? The speed you calculated, it is 6. So 6 times, what is your time? Time you're given, it is what? 2 minutes. So you know that 1 minute is what? 60 seconds. What about 2 minutes? 2 minutes is about 120 seconds. Just multiply this by 2. So 120 what? Seconds. So you say 120, which is equal to, so what is your distance? What will be your distance? You say 6 times 120. What are you getting? 720. you know the units for speed, meters. So this is what you need to do. So like this, you've answered this question. This is how you need to answer it. So this is how we need to go about this question. Let's make sure we revise through, we know how to go about all these calculations that I'm doing. So if you are not able to see, make sure the screen you are watching this using a full screen so that you are able to see these small words. So we move to the other part. We move to this question here. The question is saying, calculate the frequency of a sound wave with speed, this speed, and we've got a wavelength of that. So we only have one equation under waves that gets to summarize everything. So it's saying calculate the frequency of a sound wave with speed 340 meters per second and wavelength 0.5 meters. So we only have one formula, which is velocity is equal to frequency times wavelength. So when we want to calculate for frequency, we divide both sides by wavelength, such that these two cancel out. Then you are going to have frequency, which is equal to velocity over wavelength. So frequency is equal to what is your velocity? Your velocity is 340. What is your wavelength? 0.5. Then what is your answer there? You say 340 divided by 0.5. What is your answer? 680. So I'm getting 680. So I say 680. Then what are the units? Is like this. These are the units. Then I'm done. I've calculated the what? The frequency. That's how I need to calculate frequency. I move to these last questions. This is the last question that is here. How can I go about this last question? So it is saying, would this sound with a frequency calculated in B1 be heard? The answer is yes. Have you seen? The answer is what? Yes. How now? How can this be heard? Justify your answer. So the simple one that you can go with, you just say because it is within the range, between the range of what? The range of 20 Hz to 20,000 Hz. 20,000 Hz, like this. Have you seen? You know that a person gets to hear sounds from 20 Hz to 20,000 Hz. This is the audible sound range. So the sound will still be heard because it is within this range. This is a simple definition that you can put out. This is how you can answer this question. So this is a simple simple reason, but we've got a lot of reasons that you can give. So if you know one, you can put that reason. We are not only limited to one way, one answer. Physics or science is very broad. It's not only limited to one answer. So this is not limited to one answer. It is broad like that. So we've answered this part. Hope you've understood. You know how to go